I welcome you back to the Christmas edition of Formulae, Stoichiometry and Mole concept. So item 10, a materials lab is summary decomposing lead-2 nitrate to produce lead-2 oxide for further processing. During one run, the gas analyzer detects 2.8896 times 10 power 25 molecules of nitrogen dioxide were released. The decomposition process is represented by this equation. We are also having this information in the bracket. So what do they want? They want us to calculate Roman 1 mass in grams of lead-2 nitrate. Mass in grams of lead-2 nitrate. Mass in grams of lead-2 nitrate, but we are given molecules of nitrogen dioxide. Molecules of nitrogen dioxide, that is the information which we have. So what shall we do in this case? We shall start with the molecules of nitrogen dioxide that are given. So we start with molecules of nitrogen dioxide. We use those molecules to find moles of nitrogen dioxide. We convert molecules to moles of nitrogen dioxide. Then we use moles of nitrogen dioxide and the given equation to find moles of lead-2 nitrate. They want mass in grams of lead-2 nitrate. Then obtain later on obtain mass of lead-2 nitrate. Mass of lead-2 nitrate. So we start with converting from molecules to moles of nitrogen dioxide. So recall that what do we do from the mind map? What do we do when we are converting from molecules to moles? The relationship between molecules and moles, that is the Avogadro's relation, as in 1 mole is equal to 6.02 times 10 power 23 molecules. Now we ask ourselves, how many moles account for these molecules which have been given in the item? So how many moles contain these molecules? And cross multiplying, we shall have this times 1. We shall have these molecules times 1, then divide by 6.02 times 10 power 23. So as a result, the required number of moles we shall have this over 6.02 times 10 power 23. We saw earlier how to convert from particles to moles. If you are watching this for the first time, I'll refer you to the previous videos on the groundwork on mole concept, where these concepts have been explored. So we obtain, in this case, we obtain 48 moles of nitrogen dioxide. Now we convert the moles of nitrogen dioxide. We use these moles to find moles of lead-2 nitrate and the given equation. So the equation in this case, we are relating nitrogen dioxide to lead-2 nitrate. We are relating nitrogen dioxide to lead-2 nitrate. And from the given equation, look at that equation because you have this item. Look at it carefully. You will realize that, first of all, what must be on your left is what you have, and on your right, what you want to obtain. So from that equation, you realize that there are 4 moles of nitrogen dioxide which are produced by 2 moles of lead-2 nitrate. There is a 4 nitrogen dioxide and a 2 on lead-2 nitrate if you look at that equation carefully. So if 4 moles are produced by 2 moles, then what of the 48? The 48 will be produced by 2 over 4, then times 48, and in this case we obtain 24 moles of lead-2 nitrate. Now we have 24 moles of lead-2 nitrate. We have moles of lead-2 nitrate, we find mass of lead-2 nitrate. What do we use? Converting from moles to mass, we apply number of moles. Number of moles is equal to mass over RFM. So we have number of moles. The number of moles are 24. Mass, we don't know mass. We want to find the mass. Then RFM, from the information in the bracket, PB is 207 plus, there is this bracket, then 14, that is capital N plus 16 times 3. Capital O is 16, but there are 3 of them. then close the bracket times this 2, which is down here. Then we shall have 24 is equal to mass over computing all that we obtain 331. So cross multiplying, our mass will be 24 times 331, and this gives 7,944 grams of lead to nitrate. That is approach 1 to item 10, Roman 1. Then for the technical approach, we use the equation directly. The equation says that 4 moles of nitrogen dioxide are produced by 2 moles of lead to nitrate. Then you ask yourself, which information is provided? Which information has been provided for nitrogen dioxide? For nitrogen dioxide, what do I have? For nitrogen dioxide, the item has given me molecules. Take note of that. The item has given me molecules. So here, I substitute what 4 moles mean in terms of molecules. We know that 1 mole, those are 6.02 times 10 power 23 molecules, but these are 4 moles. So we shall have 4 times 6.02 times 10 power 23 molecules. I'm using molecules because the item has provided me with molecules. Do not substitute here molar mass. Then are produced by, you ask yourself, these molecules of nitrogen dioxide are produced by, for lead to nitrate, what do I want? For lead to nitrate, I want mass. Then we substitute molar mass of lead to nitrate, but these are 2 moles. So 2 moles, we shall have 2 times the RFM of lead to nitrate. 207, that is PB, plus 14, capital N, 16 times 3, capital O. There are 3 of them, but each is 16. Then multiplied with these 2 here. And these are grams of lead to nitrate. Then computing, so here if we multiply 4 times 6.02 times 10 power 23, we obtain these molecules of nitrogen dioxide are produced by, also here if we multiply, we obtain 662 grams of lead to nitrate. Then what of 1 molecule? So if these molecules are produced by 662, what of 1 molecule of nitrogen dioxide? So 1 molecule will be produced by 1 molecule will be produced by 662 over 2.408 times 10 power 24. We shall have this over those molecules. That is for 1 molecule. Then what of the molecules in question? Molecules of nitrogen dioxide in question. These will be produced. So here we multiply this fraction times those molecules. And these are grams of lead to nitrate. As a result, we obtain the same answer, 7,944 grams of lead to nitrate. So that is item 10, Roman 1. So we are going to proceed with item 10, Roman 2 in our next video.